Now that we know how to write balanced formulas, let's look at how to name ionic compounds and molecular compounds. First thing, there's two sets of rules. We need to determine whether it's ionic or molecular or covalently bonded. Really simple. An ionic compound is a metal bonded to a nonmetal. Molecular are two nonmetals. Now we also know about metalloids. We're going to treat metalloids as nonmetals when it comes to naming. If it's ionic, real simple. The metal always comes first, and we just say its name. So if in our example is NaCl, our name of the metal is sodium, so the first word is sodium. Now what we do is we change the ending of the nonmetal, or the second word, from chlorine to chloride. So if we're talking about chlorine, we're just talking about the gas Cl2 chlorine gas. When we're talking about chloride, we're talking about the chloride ion Cl with a -1 charge. So again, we said the order is always cation followed by anion. Metal always found metal always followed by nonmetal. We write the full name of the metal. We don't change anything. Now the ending of the nonmetal, some of them change slightly, like oxygen instead of oxygen forms oxide. And a lot of these we've heard before. Chloride, hydride, nitride, sulfide, phosphide. So we're just changing the ending so that it's IDE. All right, let's look at a couple examples. All right, first we have lithium and chlorine. Lithium, Li, it's in group 1, so it forms +1 ions. Chlorine is in group 7 or 17, so it forms -1 ions. So here we don't have to do the switcheroo because it's +1 and -1. We just write LiCl. Now for naming purposes, we write the name of our cation, lithium, followed by the name of our anion with the ending change from chlorine to chloride. So lithium chloride. Next one, calcium and fluorine. Calcium is Ca with a +2 charge. Fluorine is F with a -1 charge. Since they are different, we have to do the switcheroo. So we get CaF2. And the name here, since it's Ca, we call it calcium. We call it calcium. And fluorine becomes fluoride. Aluminum and sulfur. Aluminum is Al with a 3+ charge. Sulfur is S with a -2 charge. Since they're different, we have to do the switcheroo. Al2, S3. Naming wise, aluminum, and now we change the ending of sulfur to sulfide. Ag is silver, it has a +1 charge. Iodine is I with a -1 charge. They balance each other out. So our formula then is AgI, and our name is silver iodide. Again, the ending just changes from "ine" to "ide." Last two examples, we have Cu, which is copper, with a +1 charge. You can just write plus, you don't have to write +1. And nitrogen forms a -3 charge. Here we have to do the switcheroo because they're different. Cu3N, I'm sorry. We get copper nitride. I don't know why my pen is doing that. Last one, Fe3+ oxygen is 2-. Here we got a typed out version of the answers, maybe a little bit easier for you to see. Again, we do the switcheroo to get the balanced formula, and to get the name, all we do is we name the ions. All right, we have polyatomic ions also. The ones that we've done so far, the ions are just made out of one atom. Now we're going to look at a group of atoms that have a charge. Those are called polyatomic ions. Polyatomic, more than one atom or many atoms, and an ion, meaning it has a charge. We keep these guys together. They're one unit, and they'll have a specific name for the one unit. So like here, NH4 with a +1 charge is the ammonium ion. One nitrogen bonded to 4 hydrogens, and it's lost an electron along the way, so it has a +1 charge. Nitrate is the NO3 ion with a -1 charge. Again, it must have gained an electron from somebody. It's always 1 nitrogen and 3 oxygens, always has a -1 charge, always called nitrate. So like here, when it's bonded to Na forms a +1 ion, nitrate's a -1, so they balance out. We don't have to do a switcheroo. Same thing with the KNO3. Again, the name of this would just be potassium nitrate. Potassium is K, nitrate is NO3, so therefore the name is potassium nitrate. What do we see here in this one with the MgNO3 parentheses 2? All right, we have parentheses in there. The only time we use parentheses is when we have more than one polyatomic ion. Here, if we think about our charges, magnesium has a +2 charge, nitrate has a -1 charge. Again, we ignore the 3 on the oxygen. That has nothing to do with the charge. The charge is always written as a superscript, and we just look at the charges. We have a 1, so we just bring it on the inside next to the magnesium. The 2, we bring it on the outside. If we didn't have parentheses, it would be MgNO3 2, and that looks like you have 32 oxygens. That's not what we have. We have 2 groups of NO3, and that's why we need the parentheses. We have 1 Mg for every 2 NO3s. Aluminum nitrate, the last one here, aluminum has a +3 charge, so we need 3 groups of the NO3. All right, here's a list of common polyatomic ions that you need to memorize. The sooner you know these, the better off you're going to be. These are going to come up the rest of the year. There's no particularly easy pattern for these, because there's always an exception to the rule and that sort of thing. Here they are. Nitrate, NO3 with a -1. Hydroxide, OH with a -1. Cyanide, CN with a -1 charge. Sulfate, SO4 2-. Carbonate, CO3 2-. Phosphate, PO4 3-. We have one polyatomic cation. Remember, cations are positively charged ions, and that's the ammonium ion. This is a very, very small list of ions. There are thousands of polyatomic ions. We're not going to talk about all of them. These are the ones that you need to recognize that come up very, very often. All right, how do we recognize these? If it ends in IDE, if we just have a name, if it ends in IDE, we look on the periodic table. Chloride, oxide, bromide, all of these end in IDE, and they're monatomic ions, meaning there's one atom there. 2 exceptions, there's always exceptions. There's the hydroxide ion and the cyanide ion, which we just talked about. If it doesn't end in IDE, it can end in ATE or ITE. That means it has oxygens bonded to it. If we go back to this chart, we see nitrate is nitrogen with oxygens bonded to it. Sulfate is sulfur with oxygens bonded to it. Carbonate is carbon with oxygens bonded to it. Phosphate is phosphorus with oxygens bonded to it. So again, by studying these, it makes your life a lot easier because these keep coming up constantly over and over again.